All right, so welcome once again to the ninth session of this program. Um, we've come a long way, as I said initially, and we still have a long way to go. So today we're going to be looking at introduction to Pandas. Pandas is another library in data science. They are going to be using a lot. You're actually going to be using the Pandas library more than you use the NumPy library, all right? So it's essential that you pay enough attention because we're going to be giving you the fundamentals, explain the fundamentals and the foundations of Pandas, right? So you have an idea. So as we're looking at it again tomorrow, it won't sound or look strange to you. All right. So just to give you a head start, um, when you think of Excel, right, those of us that are familiar with Excel, Microsoft Excel, you would also the equivalent of Excel in Python is Pandas. So everything you can do in Excel, trust me, you can do much more with Pandas. All right. I'm going to introduce to what the data frame, or rather the data type that we're going to be working with in Pandas. All right, so let me quickly share my screen. All right, so hope everyone can see my screen. Okay, all right. For those that might be having network issue, thank God we are going to be dropping the recording. In case you are not able to follow through the class, you can as well go back to the recording. But hopefully the network turns out in your favor today. So we're going to be looking at pandas. And these are the objectives of the lesson. Right? By the end of this lesson, today and tomorrow's class, right? You should be able to understand what pandas is and the data structures. All right, so note that. You should also be able to know how to perform basic operations on series and data frames. I'm going to explain what those are. We are progressing. You also should be able to understand the different data manipulation and aggregation techniques in pandas. So, although this is just a summary, we're actually going to be looking at a lot, right? The same way Excel is structured is the same way Pandas is structured as well. It's just that you are required to learn how to program, write code, and all of that to work with your data frame. But in Excel, you don't need to know how to program. You can just click around, just drag and drop, type, and all of that. But the advantage of Pandas over Excel is that Pandas can work with a lot of. It can work with bigger data sets. All right. Let's assume you have a data set of 10 million rows. I don't know how many of us is familiar with Pandas as well. Does anyone know the limit of rows that Excel can work with? So I don't expect you to know this, all right? I'm just trying to know if some of us have worked with Excel before. Can someone tell us, or does anyone know the row limits or the data limits in terms of rows or observations in Excel? Okay. Adebayo, real one. He said 1 million rows. To be up there. 1 million. Any other person? I don't know why the interaction is cold today. What's happening? Is it because of the network? Right? Just because someone has said answered it doesn't mean they're correct. Understand? So just type out your own answers too. Like there's a lot more to just sending your answers. At least I'm seeing your name, right? I'm seeing that this person is actually interacting. Also, when things come up and you are required for something or someone is required for something, just know that it's those people that I am familiar with that I'm going to call. So you don't even know how it will help you later on. All right. But I just want us to interact and just respond to any question that I ask. It's also feeling good. Okay. Okay, 1 million, 1 million. So at this point, it's not possible for a lot of persons to say the wrong answer. All right, yeah, you're actually correct. It's actually a million rows. All right, so Ozioma said 1 point something something by 16,000. Yeah, so we are all correct. All right, so this is exactly the limit of rows that Excel can carry. So imagine you have a data set that is 2 million rows, right? Just imagine you have a data set that is 2 million rows. You might be thinking that how is that going to be possible? Like 2 million rows. But once you start to do machine learning and you start to work with a lot of data, you realize that 2 million rows is actually not a lot. All right. You're going to be seeing people working with more than that. All right. So we're going to be working with 10, 20, and the likes. But we're not actually going to be doing that in the course of this program just for us to be able to be effective. So I don't want our systems I don't want our systems to crash or have any problem. All right. So that's it for that. Excel can carry maximum of 1 million rows. So now I was comparing Excel with pandas. So pandas can work with more rows, can work with more than 1 million rows. Understand? So that is where it has its advantage, right? So it has advantage of getting or working with more data than Excel. So in the case where you have a lot of data, Excel is not the best option. And the truth is that you don't even need to um, you don't even need to exhaust the limit of Excel. By the time you're working with, let's say, 500,000 rows, trust me, Excel will start hanging on most computers unless you have a GPU laptop that is very fast. But once you have at least, let's say you have like 200,000 to 500,000 rows in Excel, Excel will start hanging. So you might not be able to efficiently do your work on Excel. But in pandas, right, as long as you it work with it, right? Because um I'm going to let us know why. Basically because of NumPy, but we're going to look at that as we're moving forward. So that's just to give you an idea of how pandas is used. Right. So now the outline for today. So we're going to be looking at the overview of pandas. All right. We're going to be looking at the data structures in pandas, which are Pandas Series and Pandas DataFrame. So hopefully we cover these two data structures today. So tomorrow we move ahead with the remaining part of Pandas. All right. So so we're going to look at series, we're going to look at data frame. So let's just proceed. Then I think these ones would be till tomorrow. We're going to look at basic data frame operations. We're going to look at data manipulation. We're going to look at data aggregation, group operations. We're going to look at date and time handling. We're going to look at advanced data manipulation, and also I'm going to just touch on working with multiple data sources, right? Although this visualization with pandas, we will not dwell more on it, because next week we're going to be entering a new library that is used for data visualization. So I'm just going to give an hint of what to expect, right? So let's proceed. Um, can everyone hear me and can everyone still see my screen? And is everyone following? Oh, that was great. Idris said he used pandas, sort 7 million plus raw data today. Wow, that's nice. That's actually impressive. The fact that you're already um moving ahead shows your eagerness and your curiosity, which is which is a very good thing, because then while I'm explaining all these things, it just tries to complement what you've learned already. So that's the best way to learn, honestly, because if you come to a class with no prior knowledge of something, it's going to take you more time to understand the concept. But if you've already gone over the concepts and just try to understand it surface and superficially, the class won't really be a problem for you. That's why I always release my material before the class. But unfortunately, I was not able to do that for this particular class. I just did that this afternoon. Right, so it was beyond my control, right? So yeah, nice one, Idris. You're doing very well. Okay, so let's look at the overview of pandas. All right, so let's just try to emulate him. To make work much easier on me. Okay, so as you can see on the screen, we can see that Pandas is an open source Python library providing high performance, easy to use data structures and data analysis tools. All right, I'm going to say that again. Pandas is an open source Python library, all right, providing high performance, easy to use data structures, um, and data analysis tools. So this is just telling you the history of pandas. It was originally developed by Wes McKinney in 2008. So it's actually a very recent library. All right. So NumPy was developed much earlier than this. So you can see here that pandas is built on top of the NumPy package. So this is something that I need you to put at the back of your mind. This is something I need you to put at the back of your mind. I told us like while we're looking at NumPy that that most of the libraries we're going to be looking at in the course of this program, all of them they are built on top of NumPy. Can someone tell me why all these libraries adapted or built their libraries on top of NumPy based on what we've discussed earlier? Can someone just like who has an idea of why that is so? Who has an idea? Because I believe we said this several times. All right. All right. I'm just waiting for um more persons to answer. Yeah. Okay. I'm sorry for the delay. I was checking up something. So NumPy, so I'm seeing a lot of answers there because NumPy is fast, because power capacity due to the fact that NumPy is fast. All right, everybody that said due to NumPy speed, then we are absolutely correct. I sounded this a lot of times that the reason why NumPy is used for numerical computing is because of its speed. All right. So NumPy, if you compare the speed to the speed of um, Python list, you're going to notice a significant difference. All right. So all the libraries that will come up later on, we adapt their library to work with NumPy. So there's something under the hood that enables NumPy to act or to perform very fast computation, right? There's something under the hood that enables NumPy to perform this very fast computation. What is it? This class is going to be a very interactive class, so don't yeah. So basically, that is how we're going to, because I need us to refresh our memory on what we've been doing so far. Okay, we're all correct. It's vectorization. So I actually wanted more persons to answer. So yeah, vectorization. I'm even seeing some people that don't really answer here, which is good. So basically, vectorization is what enables NumPy to be very fast. All right, so let's just move on. Let's move on without further ado. So Pandas is built on top of NumPy package, and its key data structure is DataFrame. So you can see that now with all the libraries we're introducing, at least just one library that we introduced already, they have their own personal um data structure or data type. Who can quickly remind me of the data type we used in NumPy? What was the data type that was used in NumPy? I think we all right. Exactly. And the array, anyone you want to say. So basically, we used We used arrays all through NumPy classes. That was the data type that NumPy works on. All right. So coming to pandas now, pandas work with a different data structure, although there are two of them. Right, but the main one is data frame. It's called a data frame. So what's a data frame? A data frame allows you to store and manipulate tabular data in rows of observation and columns of variables. So you can now see the similarity with Excel. Yeah, like the same thing with Excel. Excel stores your data in rows for observation and it stores your variables in the columns. So the same thing we have in pandas. So the founders of pandas actually were able to create this very nice data structure that presented your data in a way similar to that of Excel, right? So we're going to look at that. We're going to see what we mean by that as we move forward. So data structures, all right. So we've talked about data structures that we have. I said data frame, but we have two of them. We have Pandas series and we also have Pandas data frame. So at a very basic level, Pandas objects can be thought of as enhanced versions of NumPy structured arrays in which the rows and columns are identified with labels rather than simple integer indices, right? So these are things I just have to be noting. So another thing with the pandas data structure is that pandas provide a host of useful tools, methods, and functionalities on top of the basic data structures. But nearly everything that follows require an understanding of this. So this is just telling us that there are a lot of things, a lot of functionality that are associated with these data structures. The same way we can do manipulation with arrays. We talked about manipulation in NumPy arrays. The same way we can manipulate pandas arrays. All right. So sorry, pandas data frame and series. All right. So we're going to look at how we can approach all that. Okay, let's just move here. Can everyone still hear me? Oh, everyone, hope you are still following. Sorry, I'm taking it very slow today. I'm not at my 100%, so you have to pardon me for the lags, and the pauses. Okay, so what is Pandas series? All right, what is Pandas series exactly? So a series is one of the core data structures in Pandas, fundamental to manipulation within the library. It represents a one-dimensional indexed array capable of holding any data type. So just don't worry yourself about all this English. We're going to illustrate it while we are doing giving examples. So it is capable of holding any data type, including integers, strings, floating point number, Python object, etc. All right. We are going to look at how we can work with Pandas series. So hop over to let's just quickly hop over to the example. So I'm going to quickly create a new. Alright. All right. Okay. So first off, before working with pandas, you have to import it as we did in NumPy. Import pandas as PD. So remember why we're working with NumPy? We imported NumPy as NP. So these are conventional ways of working with these two libraries. And I remember I told us what these things here are. Just a quick one. Can someone just remind us? We talked about these things, although you don't have to follow this. It's not like you it's necessary to follow this convention. That if you don't follow it, you are not going to be able to import the library. No, you can put anything here. You can put P here, and you can put N here. You still work in the same way. You understand? So basically, it's just a convention that everybody uses. So whenever you are seeing a code that uses pandas, they're going to see PD and going to see NP for NumPy. So this is just how we import these libraries, all right? So for pandas, we're going to first import it. Come here and just comment our code and say importing pandas library, right? So then I'll run this and it should actually run. So I'm just going to wait a little. All right, so it has finished running. All right, so please let's just pay attention. The attendance will be posted shortly. So you're going to have to take your okay. Please just give me a few minutes. Like all right, I think that should be it. All right, so let's just quickly illustrate how we work with series here. So where you import your pandas, you can quickly check the functionalities, that is the attributes and the methods of this pandas object. So to do that, you can just come here and say print and say dir and then PD. All right. So if you print this out, you're going to see a lot of functionalities. All right. So these are the things that you'll be working with PD directly. But we also have attributes that works or they're associated with the data types that we have. That is the series data type and what's the data frame data type. So to create a series object in Pandas, you use a function. So let's come here and say creating a series object. So to create a series, you use the function PD. So if you come here, you should see it here. You can see series here, right? And if you come, you can also see data frame here. All right, so these are the two functions, or these are the two things, functionalities that you can use in creating your object in Pandas. So you can come here and say pd.series. All right, so this is how we can create series. So you now need to put in a particular data into your series so you can have a Pandas series. So let's just pick an example from the one we have here. So you can see here we just initialized our we imported our Pandas library, and then we created a data here. All right. So it takes in a list. All right. It takes in a list, and then you can now use the pd.series on that particular list, and it will automatically convert it to the series for you. So if I come here and say pd.series, and I directly put a list there 1, 2, 3, 4, 5, 6, 7, and I run it. This is what I'm going to get. This is a series object, basically. This is what series is. All right. Let me just modify this thing so it will not be. I say 45, 23, 43, 42, 12. All right. So if I run this now, you're going to see something like this. So you realize that is my screen static? Okay, all right. Probably network from your end. So you have to like pass in a list into the series function, all right? Although this is a class, but we're going to that's not what we're talking about. We're going to pass this into this particular function that we're using to create the series, and it's automatically going to generate this for us. So you need to understand the attributes of series and how it differs from a data frame. All right. So we have on the left hand side, what we call index. Right. We have on the left hand side what we call index. Right. So this index is automatically generated whenever you are creating a series object. All right. So it is automatically generated. So in this case, I passed in a list. This list would be converted to a series here, and each of the elements in that list would have a particular index. All right. So we're going to see that whenever we do that, automatically we get this. If you put one more value or few more values there, 23, 11, 10, you're going to I have to put brackets here and remove this one. All right, so let's run this. So you see that any number that is added to the series list are going to be getting additional indexing for them. So you can see 23 has index of 5, 11 has index of 6, and so on and so forth. And as you all know that Pandas Python indexing starts from 0. So this is the 0th index, all right? So if you want to see more about this series, you can always use your Shift and Tab, all right? So you can see that we can actually pass index into this particular series, all right? we can actually pass our index. So in the case where we don't want to use the normal index, you can actually pass your own particular index. All right. So let's come here and say, just put comma here and come here and say index. And then you make sure that your index is the same length as your data. So if I come and say A, B, C, D, E, E, F, G, my 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So I think that's it. So if I run this, what's the error here? Okay, I think the length, you can see that the length has to match. So length of values, it does not match. Okay, I think there's one more. GH. So you can now see what we did here. We specified our index here manually. So when we specify the index, we're not going to get the casual index that we usually get. So if we don't specify any index when creating our series, we're going to automatically get 0, 1, 2, 3, 4, 5, and like that. But if you come here and specify an index, you can see that we're going to have that index. So your index here must be the same length as your data, right? So that's basically it. So let's just explore series a little bit further. So if I assign this to a variable, my series, I'll come here, and then so I want to know the methods and the attributes of my series, right? So how do I go about that? Like, this is a very cheap question. So I want to know the attribute of my series object. So basically we just showed that like a few minutes ago. Okay, I'm not saying I want to know more about this series object. I want to know the object, sorry, the attributes and method associated with my series. Okay, I'm getting some people saying I should repeat the index. Okay. So yeah, we are correct to use our print dir my series. So let me quickly just go over the index again. I told us that when we create a series without putting any index here, all right? If I don't put any index here, I've commented out the index, and I come here, let me just print my C. If I print this thing, you can see I've commented out the index. All right. So if I print my series, that I'm going to get the automatic index that every series object will have when you create them. So you'll remember that Python index start from 0. So automatically the first value here, which is 45, will have an index of what? 0. All right. The second value here, which is 23, we have an index of 1, and so on and so forth. But if you don't want to stick with this indexing, this follow com indexing, you can specify it manually while creating your pandas series. So how you do that is just to include an extra argument, right, which is index. So the index argument here takes in the equivalent length of your data here. So you can put anything here. It might not be A, B, C, D, E, F, G. It can be anything you want, but just make sure that it aligns with the number of your data here. All right. So once you do that, you're going to get a new index that aligns with the index you specified here. All right. That's basically indexing. The indexing is not really complex thing. So I just move forward. So I was asking us to tell me the function. So yeah, we got it. So there's dir. So if I run this, I'm going to get a lot of things, like a lot. You can see that when we did for pandas, it was not even plenty because what we'll be working with mostly in pandas are the data structures or the data types, which are series and data frame. So for the series, these are the things that you can do with it. These are the methods. Um, these are the functionalities, the attributes. So if you are curious, you can as well just explore them. Understand? You can explore. You can check it out and see how it works. So you can see we have a lot. We have to Excel. So just to Excel is basically to convert your series to an Excel um, data, and it will automatically save in your computer. You can now open it with Microsoft Excel or any other CSV Excel file reader. So you can see we have to CSV here. So the same thing to convert it. So we have a lot of things here, right? So the truth is that you would not even use like you will never use like 50% of them, up to 50%, right? So they're just only a handful that you'll be using consistently. That's one thing about programming, right? That is why you'll hear people telling you that you should focus on those things that are relevant. Because if you try to learn everything, you are going to be inefficient because most of what you're learning, they won't be relevant in the long run. So you just need to focus on those things. So it's not everything you'll be using here, but is sometimes you can just check them out, and you might not know when a particular method will come in handy. All right. So that is why Python actually gives us this access to understand our objects. So we can easily use Shift and Tab because they know that people might forget some things sometimes. You might forget the arguments for a particular function. You might forget the attribute that you wanted to use, like the function that you want to use to do a particular thing. So you always have access to all these things, and this dir is one of them. So you can just quickly glance through it and look for that thing that you've forgotten here instead of googling. Understand? So sometimes you might not even have data. So all these things doesn't even require data at all. All right. So these are just a lot of the things that um, we're going to be working with in Pandas series. All right. So let's quickly. Okay. Let me just show you some. So let's look at this index. Index. Yeah. So this particular function will return the index of your series. All right. Return the index of your series. All right, so I'm going to be posting the attendance now. Let's just give me a few minutes. So I'll give us a few minutes to just quickly um so just do the needful, all right? Just do the needful, just open the link and then write your name. All right, so the attendance has been posted. You can just go and put down your name. All right. So let's just continue because of time. So you can use this index. I'll come here and say series or my series dot index, right? If I run this, you see I'm going to, okay, it's not a function, basically, it's an attribute. So let me take this off here and create a new cell. All right. Okay, so if you use this index attribute, you're going to see it's going to return the index of your series for you. All right. So you can see that it returns the index as a list. All right, it returns it as a list. So the same thing for value. We have values here. So sometimes when you might want to extract the values from your series, you can as well use this particular function. So if I come and instead of index, I say, I'm gonna do this here. For, I come and say my series dot values. All right. You're going to see that it's extracted only the values from my series. These are some of the things you can actually do, right? Some of the things you can do with your um series. So you can even just quickly pick random one. Okay, let's check out this dict to dict. Let's see what it does. Let's come here and say my series to dict. This is just like show you how it works. So you can see it converted the series to my dictionary. You can see that it has the key here is the index followed by the value. All right, so it converted it to a dictionary. So there are a lot of things here. You can see to list, right? Also, you can as well just explore them and see how you can work with it. There are lot of functionalities here, lots of them. Lot of them. So let's just move ahead because we have a lot to talk about. So that is we're going to look at some other things in my series. So now, what are the characteristics of a series? I've already showed you some things already, but what are the characteristics of series? First of all, it only takes in homogeneous data. All right, it takes in homogeneous data. Unlike homogeneous data, basically mean it takes in one type of data. All right. So unlike a data frame, which can contain multiple data types, a series is one dimensional. I can only contain one single data type. So if I come here to my series and I change this to um, let me see, let me create a new series here. Okay. All right. So come here and create some series with mixed the types. If I come and say PD series, and I come and say 1, 2, 3, let's say carrier X, all right, let's say 4, 5, 6. If I come here and I do this, okay, so it was the point. So we're going to see that in this case, when we are creating our series, most of the time you specify the data type of your series. All right. So if you don't specify the data type of your series, it's going to generally give you an object data type, which is actually not efficient sometimes. So most of the time, your series the data in your series should be homogeneous, all right? It should contain just one type of data, right? Unlike the data frame, we're going to see how the data frame works. Data frame actually has multiple columns, and each column would contain a different type of data, all right? So in this case, you can start introduce something here, which is D type. So the D type is used to specify the data type that you are going to be assigning to this particular data you are creating here, right? So if you specify it, it's going to give you error because you actually can't have two data types in a particular data. So if I let's say I just remove this. It's going to actually give me something. And you can see the data type here is object data type. So object data type, as we saw in NumPy array, is a data type that accommodates multiple data or data types in your array or your Pandas series, right? So, but it's usually not practical because most of the time your data or your data frame or your series, you are always going to be having one type of data for each column or each variable. All right, so that is basically what um we mean by homogeneous data in this case. So we have flexible indexing. I think I've explained this already. The index of a series can be explicitly defined or implicitly created. So I've demonstrated this to us already. All right, so the indices can be numbers, it can be dates, as someone illustrated on the group, or even streams. So you can be flexible or you can be creative with your indexing for your series. All right, so the last one here on characteristics of a series is alignment via index. So when we start looking at operations using series, you will see that operations between series, that is using our arithmetic operations, align values based on their associated index labels. All right, so when you are trying to perform, because you can actually perform arithmetic operations on series, all right, so how it performs the arithmetic operation is by comparing the index of one series with corresponding index of the other series. So it aligns and perform the operation based on the index of the two series, all right? So we're going to see that as we are progressing. All right, so you can see I've explained all this already. I've showed us how we can create a series by either using the automatic index or specifying an index manually, right, as you can see here. Now let's quickly look at the basic operations on series. So the same way you can perform operations on any data type, you can actually perform operations on series, all right? So you can actually access elements in a series by their index. So that is basically what the indexing is for in this case. So you can either use the index label or the integer location. So depending on the label or the index you're using, you're going to specify it when accessing your elements. All right. So let's quickly look at how we can do that. So let's bring up our series here. My series. So I created a series initially. All right, so we created a series before, which has this indexing here. So if we want to access any particular value, we can, the same way we use indexing in array, the same way, and list, it's the same way we use indexing here. So to use our index is just call your series name, my series, and put it in a bracket, all right? And put A here. So it is going to read your index for you in this place, which is 45. All right, your index here is 45. If I come here and I put 0, you can see that it will also give you the same 45. Ignore this warning, all right? So even if you change the original indexing, which is 0 and the rest, 0, 1, 2, 3, Python still recognizes each of these value with the original index. So there are two ways you can access them, by either using the new index you created or using the original index, which is the normal Python index starting from 0, 1, 2, and the rest. All right, so that is basically how you can access elements. So we've looked at this before, so I don't need to go deeper into it. Okay, so we've seen here that you can access by using the index label, and you can also access by using the index integer location. All right, so you can also slice a series. All right, the same way we can slice an array and it lists and other sliceable data type. You can slice a series to. All right. So how to do that is just do the same thing from here. Let me just put this accessing elements. The reason why I'm doing this is because I'm going to making this available. All right. I'm going to be making this available for us. I need to make sure that it's well documented. So let's put this here. All right, so let's see how we can slicing our series object. So we already know how to slice something. All right, so just to use the colon and indicate the starting point and the ending point. So in this case, I can come here and say my series, and then put the starting point, which in this case we said A, and let's say D. All right. If I run this, you can see it will return a series for me. All right. So we're going to return a new series with the sliced one. So you can see what we have here. So if you come and here do the same thing with my integer, that's a 0 to here is 4, right? So you can see it give us the same thing. Now you notice okay, yeah. So this is basically what you get if you slice your series. So we've actually looked at this a lot when looking at arrays operations. So I won't dwell much on that. So just know that these are the operations we can perform. We can access data, we can slice data. Now I told us that we can perform arithmetic operations with our series, right? So the same way you can perform an arithmetic operation um with your array, it's the same way you can perform an arithmetic operation with your series. And you will know that I talked about homogeneous data initially, so you can see the importance of your data being homogeneous. So you will not come and be having different data types, and so that just you would see the importance that we're moving forward. So this is just one of them. So let's just come here and actually perform some arithmetic operations. So I'm going to come here and say arithmetic operation on series data structure. So we're going to create two series. Series A, Series A. For those that watch football, I think you would understand what I just did here. All right, so series A, and you can come and say pd.series, and come here and put 4, 5, 6, 7. Let's make it simple. I'm not going to put any indexing, right? Just leave it like that. And come and say series B. Right, come and say pd.series and say 2, 4, 2, 3, 4, 5. So now I want to perform arithmetic operations on these two series. Very straightforward. So I can come and say series A plus series B. You can see it returned a series for us. So the series that it returned would be the addition of these two series. So if you come here, you see that 4 plus 2 is what? 6. 5 plus 3 is what? 8. 6 plus 4 is what? 10. 7 plus 5 is what? 12. Right? So these are the things we can do. Let's come here and say series A. Series A plus minus series B. You can see the output here, 2, 2, 2, 2. Right, so if you subtract each of them, here's what you're going to get. So you understand where we are going with this. So you can perform any other arithmetic operations. Series A, divided by series B. You can see it gives us this particular output. Okay. All right, let's look at the other ones we have. Series A, series B. That give us this. What does this particular arithmetic operation do again? Can someone remind us? The double division line. What does it do again? You are just telling me what the name is. I'm asking what does it do? You know it's floor division, but what does floor division do? All right, someone said Samuel gives remainder. Um, Olajumoke returns the remainder. All right, so yeah, that is basically what it does. Yeah, it's floor division, but it returns the remainder of your operation. Are we sure? Take a look at it again and see if that is what it does. Let's look at the other one here. That is modulus and say series B, series A. Yeah. So what would you now say this particular operation is doing? If we say this floor division returns the remainder, what does this modulus do? Hmm. Yeah, I think this is why it is very good to have this interaction. So you just refresh your memory. Like I completely understand that there is a lot we've learned. So trust me, this thing I do is very intentional. All right, it's very, very intentional, and I'm not going to blame you for forgetting some small details, which it is. Yeah, so that's why we kind of refresh our memory on these things. So actually the modulus operation is what returns the remainder of your operation, while the floor division retains the whole number and discards the decimal part of our operation. That is basically what it does. It retains the whole number and discards the decimal part. All right, so just please take note of that, like so you won't forget again. So this is, as you can see, we can perform different arithmetic operations on our series. So depending on what your work is, you might need to do these things. All right. So just take note of it. Is another thing that you can do with series. So let's proceed. Okay. So we can see that we also can handle missing data in series. All right. So we can actually handle missing. So let's quickly create a series with missing data. All right, so I can come here and say this is missing data. I'll come here and say pp.series and say 453 mp dot not a number. So this is actually how you can create missing values. All right, so and I can come and say mp.nan again and say by 12. Let's just stop here. All right. So I've created this series. Okay, I have to import np. You see that whenever I want to import something, I just go to the top. That is actually a very good practice. So anybody that's using your code, know all the libraries that you are using. Let's just quickly do this. So you can see that we've created a series with missing values. We have one here and what another one here. So Pandas series can actually help you with addressing missing values. So the function for that is fill NA. Fill NA. Alright. So what fill NA does is that it fills the missing values with the number or the value you put in the bracket as arguments. Alright. So I'm going to come here and say let's just assign this to a series NaN. Come here and say series NaN, and I come and say dot fill NA. So if you go back to the attributes and methods of series and you look for fill NA, you should see it. All right. So let's quickly check here. So you can see it here. All right. Fill NA. And if you want to know more about it, you can just use your shift and tab. Just come here, click on it, shift and tab. So it will explain what it does for you. So you can see here, it fill NA or NaN values using specified what method. So it basically just fill your missing value with a particular value, or your missing data with a particular value. So if I come here and put 0, I'm going to see that all the missing values that we have, that is in this index 3 and index 6, has been replaced by the value that we put in this function as argument. All right, so these are ways you can work with data. All right, so imagine you are working on a very rough data set, and it has a lot of missing values. So this is one method to work with it, or to address the issue of missing value. And trust me, missing values is going to be one of the most important data cleaning step you'll be doing. Right, so we're actually just starting with data analysis. It's just introducing you to the data structures. Basically, we'll be using mostly DataFrame in the course of the entire moving forward. So this series is not what you'll be using all the time, right? But you might come across series like maybe a few times and all of that. But DataFrame is what you'll be using most of the time. And in DataFrame, you'd meet a lot of missing values in each column, in different columns. So the way to do that is by using filling. All right, so let's just move forward. So you can actually fill it with any value you want. You can fill it with, you can come here and fill it with the mean. All right, you can actually fill it with the mean. So how do I get the mean for this? I don't know if this, I don't think this works on series. Fill method. Okay, yes. So now we have our mean to be 12, right? So I'll come here and put mean and say series mean is equals to this. All right, and I'll come here and now put the mean. So one way to undo missing value is by replacing the missing values with the mean. So it makes more sense to replace those, especially when it is numerical data. You replace the missing values with the mean. All right. So, but when it comes to your categorical data, you replace it with the most frequent category. So in this case, we are going to replace with the mean. And if we come here, so that it has replaced index 3 with 12, and it has replaced index 6 with 12 as well. All right, so this is how you can undo missing data in Pandas series. All right, let's move forward. So, okay, we have another method of doing that. We can also use another function called drop NA. All right, drop NA. So we can as well use drop NA. Drop NA, what drop NA does is that it drops the missing value, or it just drops all of them. It doesn't really have strength to um, it doesn't have strength to start filling the missing value. It's just like the lazy method of handling missing values. But there are times when you can use the drop NA and times when you can use the fill NA. When you don't have a lot of data, you can easily just use fill NA. But when you have a lot of data, in which dropping these missing values where it won't really have an impact on the data size, then you can use or go ahead with dropping the missing values. All right. So let's just see how we can do that in series. So if I come here and say dropping the missing values, and I come here and say all right, I say we have my series NaN. The function to use is drop NA. I don't need to put anything as argument here. Just run it, and you see that it has removed index 3 and it has removed index 6. All right, so you see that we don't have index 3 and 6 again. So this is basically how you draw. Let's say let me find a particular function here. So there's a function called reset index. So sometimes you perform some operations on your series of data frame and it will mess up your indexing. In this case, it does not automatically reassign index. It just leave you with the remaining index. So you can use what we call reset index to reset the index, right? So to go from 0, 1, 2, 3, all right? So let's quickly see how we can do that. So if I come here and I say dot reset index, I run it, you can see that it has automatically reset my index from 0, 1, 2, 3, 4, 5, 6. And there's something that happened here. It's actually retains my former index, all right? But there's a way we can work with that. So if you come here and press Shift and Tab on this reset index, let's see. What's wrong with this thing? Uh, okay. So you basically don't know why this shift tab is not working for reset index, right? But basically, when you reset your index, this is what happens. All right, it gives you the original index as you have before. All right, so you can see that it has from 0 to 6 here, and the former index was 0, 1, 2, 3, 5, 7, 8. So this thing you're looking at now, although we've not talked about it, is a data frame. So let me just quickly talk about it quickly. So a data frame, a series can become a data frame when you have more than one column. All right. That is one difference between a series and a data frame. A series has just one column. All right. While a data frame has more than one column. So immediately you go beyond just one column in your series or in your data structure, you automatically get the data frame. That's why we are seeing this formatting here. You can see we have this stylish formatting where we have like grades of ash and all of that here. So this is what a data frame looks like, and we're going to talk about it. We're going to introduce it to us today, all right, and we're going to go deeper in tomorrow's class. Hope everyone is still following me. Hope everyone is still following me. All right, all right. So in this particular case, you're going to get this index, if you use this method like this without any parameter, this former index will become a column, a new column in your data set. All right, so that is basically what will happen. But if you don't want it to become a new column, you can just indicate or say something that is drop equals to true. All right, so this is something you can indicate inside this reset index function that would automatically drop the former index here. So please be paying attention to all these things, all these small things, but they are very valuable. So if I come here and then run it, you'll see that it has automatically dropped the former index and giving us a new index. So this is a way of resetting our index when you manipulated your data or by removing certain rows and certain rows in your data that would affect the indexing. So that is just how you would mostly work with it. All right, let's move forward. So we have vectorized, or we've looked at um, how we can handle missing data by using fill NA and by using drop NA. So now let's look at vectorized operation. So you can see how everything is coming together. Pandas is built on NumPy, which makes it easy for you to perform vectorized operations on Pandas data structures. So let's assume you have a series, all right? You have a series like this. Let's use the series as let's use my series, all right? Let's use my series, which is this. Let's assume I want to perform vectorized operation. That means I want to multiply everything in my series by 2. You can easily just come here and say by 2, and it will perform it for me immediately. Can you see? Right, so this is how you can perform vectorized operation. So I just brought this up so you know that Pandas data structures can perform all those things that you can do in NumPy. All the advantages of NumPy is transferred to Pandas. So it makes your computation faster and effective. All right. So performing a large, sometimes you work with a lot of data. So this is just a very small data we are working with here, but most of the time, tomorrow's class, we're going to be introducing how to read CSV and work with CSV in Pandas, right? So at that point, you're going to be seeing quite a number of rules and all of that. So this is how you can perform vectorized operation. All right, you can do division, you can do, so like this is just what happens. Now, can someone tell me what is happening here? There's a particular terminology that this operation is using to perform this. I'm not talking about vectorized operation now. There's another operation terminology that is happening here, or another thing that's happening here, like we talked about in NumPy. We use just one value here, and in the original series we have about eight values. All right. So for we to just pass in 2 and the thing automatically adds all of this, it's based on something, all right? It's based on something that we've talked about. So can someone just tell us what it is? I'm waiting for more answers. Okay, I think I'm satisfied now. All of you that said broadcasting, you are correct. You are absolutely correct. I'm so happy that we still remember all these things that we're talking about. So broadcasting is the concept that allows you to spread out a value to match the size of another data that you want to perform an operation on. All right. So this what is happening here is just broadcasting. So this should be telling you that this thing is built on top of NumPy. So almost everything we've been talking about in NumPy, they're applicable It's just that the data structure is quite refined here. So this is just like NumPy wearing a clothes. That is just how you see pandas. It's like pandas is like NumPy wearing a fancy clothes, right? Remember in NumPy array, it's just like a bracket with numbers and it's just boring, right? But pandas data structure, which are series and data frame, they actually are more advanced, all right? And they are structured in a way to help you interact with it better. So that is it for vectorization and broadcasting. You can perform this kind of operation on series objects. All right, so let's move ahead. We're going to be rounding up very soon. So now okay, basically I've showed us this already, that you can convert your series to other data types such as a list or dictionary. So I showed us this. Okay, I think I showed us list, but now this is why you can explore, you can choose to explore all the functionalities of pandas, right? Of pandas series objects. So you can just play around with them and have an idea on what it can do. So you can convert, okay, let's just quickly illustrate that here. Let's say converting series to um lists. So you can actually convert it to list. I come and say my series dot to list. All right. So if I run this, what will happen is that it extracts the value of my series. So something you should know is that when you're working with series, the most important data here is the value. So the indexing is just there to make reference to each data. But when you're working with the series, the arithmetic operations, all of that, everything is performed on the value. All right. Also, we have that here. We have you can see that when using this to list function, it automatically generates this list. So you can use it to do whatever you want to do. So it's very flexible, very flexible. The same thing for my dict. You can come here and say to it. All right. You can see what it does here. It takes the index as the key and the value here as the value. Right. So that's quite straightforward. So that's it for series. Series is a very powerful data structure in pandas. What have we looked at so far? Looked at what series is, right? That is one of the core data structures in pandas, fundamental to data manipulation within the library. It represents a one-dimensional, that is very important to know, one-dimensional. So if I come here and say my series dot shape, you can see that you can see the shape here. This represents one-dimensional data, right? So at this point, you'll be saying like, all this we are doing is NumPy because the same shape attribute you have in NumPy, the same shape attribute you have in Pandas series. So when I tell you that Pandas is a bit on top NumPy, I wasn't joking. You understand? So the shape here is 8 by nothing. That is one-dimensional data. So the series are one-dimensional data. Unlike data frames are two-dimensional data. So we don't actually have anything higher than two-dimensional in pandas. All right. So the highest we have is two-dimensional, which is used in data frames, and the lowest is one-dimensional, which is for series. All right. So it represents a one-dimensional indexed array capable of putting in data type. All right. I've said this already. We looked at how we can create a series. All right. We looked at the characteristics, homogeneous, flexible, indexing, alignment via index when performing arithmetic operation. We looked at how we can manually specify the index in a series. We looked at how we can access the values, right, by using indexing, right? So either you use the manually specified index or use the original index. We looked at how we can slice series. We looked at arithmetic operations we can perform, right? We looked at how we can handle missing data by either using fill NA or drop MA, all right? We looked at vectorized operation and broadcasting. We looked at conversion to other data types. So in this case, we just use list and dict. We can actually use other convert other data types too as well. So you can explore that. Now we are just going to introduce data frame. All right. So DataFrame is the Oga of Pandas. This is what you'll be working with 95% of the time. This is what you're going to be working with, what? 95% of the time. When you talk about Pandas, you talk about what? DataFrame. All right. When you're comparing Pandas to Excel, what you're comparing is actually DataFrame in Pandas to the layout in Excel. So let's quickly look at what DataFrame is. So a DataFrame in Pandas is a two-dimensional size. You can see now the difference is coming out. Two-dimensional, all right? Size mutable and potentially heterogeneous tabular structure. So if I start asking you, can you just list two differences between Pandas and series? You should not have a problem with it, all right? So it is conceptually similar to a spreadsheet. Can you see it now? So they made it similar to a spreadsheet, so you'd have the intuitiveness when working with it, right? Especially for those that have worked with spreadsheet before, or an SQL table. That's for those that have worked with SQL before. So, or a dictionary of a series subject. So data frames allows you to store and manipulate data with integrated indexing for both rows and columns, making data manipulation easy and intuitive. So Pandas is a very, very good data structure, right? Very, very good data structure. So I'm just going to go over the characteristics of a data frame. So first off, we have labeled axis, all right? So both, now, in series, we didn't really talk about columns because it's just one particular column that is there. So in data frame, we have more than one columns, all right? We have both rows and columns. So both rows and columns in the data frame are actually labeled, all right? So you can index them using the name. You can index a particular column or you can index a particular row, all right? So the columns usually represent the variable and the rows representing the observations, all right? Now, another thing, it is heterogeneous, which means it can contain several data types across columns. So each column actually would hold one data type, all right? But another column can hold another data type. So maybe one column has integers, another column have string, another column have dates, and so on and so forth, all right? So unlike NumPy arrays, which require homogeneous data throughout, and series too, right? So size mutability, data frame allow for manipulation of size. You can add delete rows. So these are just manipulation. You can manipulate your data frame to how you want. We're going to be looking at all of that moving forward. So efficiency. Pandas data frame are built on top of NumPy, so this is not new to us, making operations on them extremely efficient, particularly for what large data type. So how can we create a data frame now? Let's look at how we can do that. All right, so just stick with me here. We'll be rounding up very soon. Creating a data frame. Okay. Remember how we created Pandas series by using pd.series. Someone asked, must it be capital letter? Yes, it must be capital letter. All right, it has to be capital letter. So it's not actually a function per se. It is a class, all right? So that is the notation for a class. So that's not our business to know. So, but to create a data frame, you use the same format, but you use a different class, which is data frame. So you can see that the D here is capital letter and the F is in capital letter. So don't come and meet me when you're trying to create your data frame and your F is in small letter or your D is in small letter and you're saying, I don't understand what my code is doing. Check it very well. Make sure that F is capital letter and D is capital letter. What I tell you about, remember what I told us about Python being case sensitive. Python is very case sensitive. You need to know that, all right? So every syntax has a particular case that it follows. If you make it capital letter, it will give you error when it should be small letter. So in this case, this is how you should write your data frame. I know why I'm saying this because most people would encounter this error. So if I see a question talking about this thing, I will just ignore you, right? Because I'm saying it loud and clear here. Make sure that your data frame has a capital D and what? A capital F. All right, so what value do we pass into this data frame function? I'm just calling a function just for simplicity's sake, all right? So first off, we have what we pass into a data frame is usually a dictionary. My dict. So Python dictionary is how you can create a data frame. So how do we create dictionary again? By using key value pair. So I can come here and the key in a dictionary corresponds to the column and the value corresponds to the row. All right. So that's basically what we do. Right, I understand. So you would have to specify your key. The normal way of creating a data frame, all right? So in this case, we can say name. I can come here and the value is always a list because you want to have multiple columns, all right? The value is always a list. So I can come here and say first name Emmanuel, second name Muhammad. I hope I spelled that correctly. Third name, let's say George. Fourth name, let's say Amujama. All right. So that's basically how you create a dictionary. So you just ensure that the list, the value you are passing into your dictionary should be a list. All right, it should be a list. So let's just add some other names. Let's say okay. So let's work with this. Another thing you need to know is that every value you are passing should have the same length. All right, let's say country. Come here and say. So I may assign different countries to you. So you can say Nigeria. Right, I can come and say Nigeria again. Just random, I can say Zimbabwe. And come and say which one should I? Can say Ghana. I can just come and say let's say Egypt. So make sure that the 1, 2, 3, 4, 5, 1, 2, 3, 4. So the all the lists should have the same length. All right, all the lists. Let's just add one more. Let's say occupation. All right. Let's say data scientist. Let's say lawyer. Let's say doctor. Let's say engineer. And let's say chef. All right. So these are the different, it should correspond to the. So we've created a dictionary of key and value pair, right? We can now run it and then pass the dictionary to our data frame. So if I come here and say my dict, Pandas will automatically convert the keys that we have here, name, country, and occupation, to the columns, all right? And then it will take the values for each key and make it a row, right? It automatically assign a row and index to this dictionary. But if you want to specify the index, you can actually come here and specify the same way you can specify your index for series. So let's say A, B. Make sure your index is the same thing. D, E. All right. So you can see that we've changed the index. So this is the layout of a data frame. This is how a data frame would appear when working. So when we're working with real data, you would see that the data frames have plenty columns. So it's going to span around your screen and it's going to be lengthy. So this is just a visual on what to expect, right, on data frames. So you can see it here. You can see the key is what your column. You can see we have 3 columns here, which is on like series where we just have one. We have a row here, and we have columns. So you can actually index anything. You can bring out the column. You can by coming and saying, let's say, I want to say df data frame, df for data frame, right? So I want to extract one column, maybe name. Come and say df. You use the same indexing, right? And put the name of the column. If you run this, it's going to return a series object for you. You understand? Can you see? This is a series. So this is the interplay between data frames and series. When you want to get a particular column from a data frame, it returns as a series for you. You understand? So all the functionalities that you can perform on series, you cannot perform it on this single column. Do you understand? So in case you want to work on a particular column, you can just extract it. If I come here and say occupation, see to give me the occupation here, right? So basically that is how it works. So if I come here and let's say I want to extract 2 and say name, right? I think I'll put double bracket here. I can extract 2 columns, all right? But remember that you put double brackets here because it's a list. You're passing in a list of columns, right? So it will give you a data frame. Why? Because it is more than one column. But if it's just one column, it will return a list for you, all right? So you can also index the row. If I come here and say df.a, the same thing will happen. It will return a list df.a. What is the problem? Yeah. Let's say, why is this giving me errors? All right, so but we're going to look at how to do all this thing. Although this is something we're going to be looking at, ilog and log and all of that. But the main aim, I just want to introduce Pandas data frame to us today. So when we continue tomorrow, we can just move straight from here. All right. So you can actually index the colon, all right, and index 0 as well. Hope everyone is still following. Please let me know. Hope everyone is still following. All right. All right. All right, great. So we are going to be stopping here for today, but just know that to index the row, you use ilog, right? So if I come and say, if I say log is going to give me the variables or the list of one particular row. You can see manual, Nigeria, and data science. So if I come and say B, give me the next person, Muhammad, Nigeria lawyer. So this is how you access the row. But if you want to access the row using original index, you have to put I at the beginning of your ilog. So what this I mean here is index location, all right? Followed by I means index, log means location. So if you put I here, you have to put an integer value which corresponds to the row that you want to index. If you not put I here, you have to put the label itself that you specify, which is this one that with this index. So you have to put A. All right, so that's how you index a row. But the other method of just directly indexing is only for column. All right, so whenever you do this, you index only column. The reason why we got an error where we did A was because A is not a column. All right, so if you want to index a row, you have to put either ilog, right, or just log. So that is going to be it for today, guys. We've covered a lot, right? We've looked at pandas generally. So we'll look at tomorrow. We're going to continue from here. We're looking at common data frame attributes. We're going to look at basic data frame operations. We're going to look at data manipulation, handling missing data, understand, data aggregation, aggregate function, data time. So we might not necessarily exhaust everything tomorrow, but we're going to cover a lot tomorrow too. So that is going to be it for today. I believe you've learned a lot from this class. So it's question time as usual. I'm actually not going to be taking a lot of questions because I really need to go now. So please, if you have questions, I'll take at most 5 persons. So if you have questions, let me know. All right, Treasure, Ozioma, and Marcelinus. Okay, that is it. I think that is the 5 questions I'm going to be taking. So I'm going to be taking the first 5 persons here. Marcelinus, Ozioma, Treasure, Idris, and Precious. Okay. All right, Marcelinus, please go ahead and speak. You're on mute now.
Okay. Good evening, sir. My question is this. I'll take you a little bit back to ask you just how can you ask someone to impute a particular value, that is, input values for NumPy? That is, if you want someone to input values for NumPy, there's any function that will allow you to input values, not generating values, because the functions we have will generate values for you. But I want a situation where you can input values maybe on papers that you can input them into NumPy.
Yeah, I think we demonstrated how to input values directly. If you create your NumPy array, you can if you want to create NumPy array, you can use np.array, which is a function. And then inside that function, you put a list of values that you want to be converted to array. So I don't know if that's what you mean, but yeah, you can impute values for NumPy, and yeah, it's that straightforward. Or do you mean something else?
This is what I'm trying to say, sir. Now, for instance, I have my values on papers, or let me say I don't have these values, and I want you to input them directly. That is, it will ask, enter the number of values you want, then you input them as in the number of elements you want. You enter them. So I don't know if you have a function that can automatically do that without generating values for you. Because from what you are saying is like we're assigning elements to a particular array. But I don't want it that situation. I want it in such that the user now will be interpreting his own values.
Yeah, let me quickly share my screen and demonstrate what you're saying. Okay. So just let me know if this is what you mean. Yeah. So I have, let's say, np.array. So you mean like imputing the value directly into this array? Is that what you mean?
Yes, you imputing values, not assigning already. As now, maybe you create a list, already you have assigned values. But I want it in a situation where someone will just decide to impute his own values without.
Yeah, we looked at this in our NumPy class now. That was the first thing we did, where we will just put a list and then any value we want to write, we can just put it there and then run it to convert it to array. If you want a 2-dimensional array, you would come here and just put 2 brackets and do something like this. Is this what you mean?
No, this is not what I mean. This is what I'm okay, this is what I'm trying to explain. Now, a user, you say input the number of arrays. On your display screen, it will tell that input the number of arrays. Then you put in the numbers, as in the total number of elements you want. After then, it will tell you that enter the elements for your array. Then you enter, some persons may decide to enter 15, 20. Now I'm looking at it as a user. I'm not looking at it as a, yeah.
Yeah, it's a different thing entirely, all right? There are different things you can do in Python. Like we have a function called impute, All right. We have the
Yeah.
function called input, and
Yes.
can actually just so we can easily use this input to ask the user to input something. All right. So
Yes.
let's um so this is out of the scope of what we are doing basically. All right. It's not like you'll be using it for anything like that. Although it might come in handy once in a while, but this is something that you would probably not even use. This is for mostly for people that want to build a website that would have a user interaction where you would ask them to input something, all right, and they can now input a particular value. So you can just explore this function on your own. You see that this function here, it's read a string from standard input, blah blah blah, and all of that. So this you can explore it on your own. I believe if you have the time, but it's just out of the scope of what we are doing. All right. So I mean quickly run this. So you can see I run this input now. I can easily just input something and it will output
Yes.
56, right? I can come here and input like a list of string as a user and say 689. It would, you get, so if I want to convert it to an array, I can assign it to, let's say, I can come and basically add NumPy array. So see, Marcelinus, I understand what you're saying,
Yes.
but you can explore on your own, but this is just out of the scope of what we are doing. All right. So, but you
Thank you.
repeat functions to get that done. All right. So next person, please. Hope that answered your question.
Yes. Noted, sir. Thank you.
All right. Okay. So who else is on the list here? Um others drop their hand or what? All right. Treasure, Treasure, please ask a question. Treasure, you are on mute. You can just unmute yourself and ask a question.
All right. Good evening, sir.
Yeah, good evening.
Thank you so much for the class. It's been exciting, challenging, and interesting at the same time. So, but please, mine is not really a question. I is with regards to last week's assignment. I mistakenly handed in an empty file without the answers. I got a mail today that I didn't answer the questions, and when I went back to check, it was just the downloaded question without answers I handed in, and I handed in on Thursday, even before the deadline. I'm always handing in my assignments before deadlines. So please, I sent that screenshot in the question and answer session this morning because that was when I got the mail and I was really sad about it, pleading for a chance to resubmit.
Um, so this was what I spoke about before we started this class. Like, you shouldn't be having this kind of issues. Like at this point again, like this is the fifth week, ninth class. I think this would be the fifth assignment, fourth assignment basically. So it is not an excuse. Like it is. I said it at the beginning of the class. I don't know if you were here or not, but um, you should have been able to know how to navigate your way around this issue already by now. So I don't know what I can do for you at this point, right? But that is just it, right? That's just it. But thing is that
So it's a mistake. I
just
the empty file.
yeah, I know it's a mistake, but it's not something that. Anyways, you know what? Just to avoid long talk, just send me a DM. I'll send me. But I'm very very tired with all these kind of excuses. Honestly, like after grading something, you come up and with certain issues that have been addressing over time. Anyway, just send me a DM and we'll look at how we can go about this. All right, so Idris, please go ahead and ask your question. You're on mute, Idris, please. Ask your question.
Please, can you hear me? Please, can
Yeah,
you
yeah,
hear
I
me?
can hear you.
Okay, good afternoon, sir.
I
Good
can hear
afternoon.
you.
Yes, good afternoon. Good afternoon. It's about this fill NA attribute. That is can fill or no data. So now,
What do you say?
can you hear?
Your voice is breaking.
Sorry, network coverage. Can you hear me now?
Yeah, go on.
So my question is about this non-null data that you have to use a fill NA to fill the new data with any value or zero or whatever. So I was now thinking that, okay, if I had to fill, can I fill those null value with zero so that I could compute, so I will not have to delete empty column or whatever it is. If I use zero to present null row, is it going to affect the output of that is the accuracy of my data? That's my
Please,
question.
can you come again? I honestly didn't get you.
I said my question is this. You talked about this attribute, this Panda attribute that has to do with fill NA.
Yeah.
So what I'm saying is that when I have a data where I have a new data, can I fill them all with zero so that it will aid in my computing? Like when I want to aggregate the data on something, can this zero that I use to represent my new data, can it affect the accuracy of my data, or vice versa?
Yeah.
So I was just curious.
Yeah. We've actually not gone into data cleaning yet, but when we start data cleaning, I'm going to show you how to approach missing values properly. All right. This fill is zero is not practical at all. I'm just showing you just to demonstrate how you can use fill NA. But most of the time, you either use the mean or you drop the colon, right? So zero is not a good approach to handling missing data at all. It's actually obviously going to affect your accuracy, the insight you get from that data. So I think that should answer the question.
All right. Gracias. Thank you.
All right. So please, I need to go now. Who else have questions? Okay, Uzioma, then Precious. All right. Uzioma, ask your question quickly, please. Quickly.
Okay. Hello, sir. Can you hear me? Good evening, sir.
Yeah, I can hear you.
Okay. Thank you so much for the class. My question is on the indexing. Like when you were doing the index, changing the indexing from 0, 1, 3, you change it from A, B, C, D. In a situation where you are working with a large data set and you want to change indexing, is there a function you write that will just change it at once, or do you have to be typing the A, B, C, D, E, F, T when you are working with a large data set?
No. Like most of the time when you want to change the indexing, you already have in a data frame, for example, if you import a CSV file into Pandas, you already have, let's say, a particular column that corresponds to the index. So you can just make that column the index. So there's a way you can do it actually. So you don't have to, obviously it's impractical to do that, understand? So don't worry, all these questions you're asking will be answered when we start going deeper into Pandas working with data frame. All right. So
All right, no
that's
problem. Okay, thank you, sir.
yeah. Oh yeah, Precious, please wrap us up so we can continue with what we have for today. You're on mute, Precious. You can ask a question.
Yeah, good evening, sir. Thank you for my habits today. My question is actually based on the last part where we are talking about the last part where we are talking about how to access row, access column, the high log and the log. So I didn't really get that part. I don't know if you can actually go over it again. Thank you.
Precious. To be honest, I don't think I can go over it again. Don't worry. Tomorrow we're going to recap from there. All right. We're going to start from there so you understand it very well. Although the video will be made available But if you still understand it, tomorrow we are going to go into this in details, and I promise you, you will understand it. All right.
Yes, sir. Thank you, sir.
All right. You're welcome. So, any other question? Any other question? Any other question? Okay. So I'm going to call it a day at this point. We've covered a lot, right? We looked at pandas and the introductory aspect of it. So tomorrow we'll continue from where we stopped. So please just get yourself acquainted with what we've done today. The video will be made available hopefully this night, so you can go over before tomorrow's class. All right. Thank you very much for your time. Thank you very much for your attention, and thank you very much for your commitment so far. Do have a nice day, and see you tomorrow. So don't forget to do the needful. I don't need to tell you the needful. Just drop what you learned today. Please just drop it because we learned a lot today, all right? So yeah, thank you very much and enjoy the rest of your day.